Sure. Yeah, you do have. What page is that on in the back of the book?
829 and 830.
Okay, so yeah, page 829 and 830 are all your conversions in there. It used to be 799. That's moved back a little bit in the new edition. Anyway, to go from pounds to kilograms, we got 88 pounds. It is actually pounds on bottom, kilograms on top. 1 kilogram is 2.2. It's actually divided by 2.2. It'd be 40 kilograms. 18 gallons. Gallons are going to go on bottom, liters on top. 1 gallon is 3.785 liters. Sounds right. Yep, 68.13. Many of your cars are 16 or 18 gallon tanks. So that's a 68 liter tank. We'll take a look at that here in a little bit too, as to how we can do that conversion. Now we'll talk about it more when we get to it. 700 grams into ounces. So at 700 grams over 1 in our conversion factor, it'll be grams on bottom, ounces on top. An ounce is bigger. What is it, 28.35 grams in an ounce? I don't expect you to have that one memorized. In my time here, I've only had one student who had that one memorized. He did not finish out the semester.
Really?
He ended up in jail. There was a reason why he knew how many grams were in an ounce. And yes, that's what he ended up in jail for. That sounds right. 24.7. Yep, 24.7 ounces. 5 meters into feet. Oops, I don't know why I put feet on the bottom there. We don't have a direct relationship from meters to feet. It says centimeters to feet, or feet to centimeters. So what I'm going to do is I'm going to change that 5 meters to 500 centimeters. Now we can convert. There's 30.48 centimeters in 1 foot, correct? So it'll be 500 divided by the 30.48. 16.4 feet.
You want us to do the first decimal and 2 decimal places?
Usually 2 decimal places is the safe way. This would be 16.40. Yeah. 7 liters into quarts. Well, is there a direct translation from liters to quarts in there? What's it say? 0.9464 liters, okay? So we have to take the 7 divided by 0.9464. Gives us 7.40 quarts. There's about a 5% difference. I believe usually they say that 1 liter is 1.05 quarts. It's about a 5% difference, a little more than a 5% difference. 42 inches into centimeters. This one we do have a direct translation. 1 inch is 2.54 centimeters. That's the one length conversion that I keep memorized, is that one. Nope, 2.54. It's just a little over 2.5. Oh, sure. It happens to the best of us. So 106.68. Well, I showed you guys that I'm dyslexic, didn't I? Okay, so if I were to tell you guys that I can throw a baseball 90 feet per second, would you believe me? Now, the thing of baseball field, baseball diamond, First base is 90 feet from home plate. So that means I could stand on first base and I could throw the ball to home plate and get there in 1 second. You think I could do that? Hardball, baseball. Is that fast? Well, what are we used to seeing speeds expressed in? What units? Miles per hour. So the conversions that we have done can be done with these compound units as well. 90 feet per 1 second is what that really stands for. And we have to get rid of feet and turn them into miles. 1 mile is 5,280 feet. So that's going to cancel out the feet. But we also have to get rid of the seconds. Seconds are on bottom, so to get rid of them, we're going to put them on top. Now, we don't have a direct relationship between seconds and hours, so we're going to go to 1 minute is 60 seconds. The seconds are gone. Now what we have is miles on top and minutes on bottom. So we're in miles per minute. We have to go one more step, get rid of the minutes, go to hours. 1 hour is 60 minutes. And now the minutes are gone and we are in miles per hour. So on top, we're going to multiply there. 90 times 1 times 60 is 324,000 miles. And on bottom, 1 times 5280 times 1 hour is 5,280 hours. We have to divide that out. Oh, what is that? 61.36, something like that. Miles per hour. I'm pretty sure I can still throw 60 miles. Have to warm up a little bit first and probably only throw maybe a dozen balls that fast before my arm gets sore. Because I am getting old. But I could probably still do it. I'd pay for it. Let's look at units like you have something that is listed as 2.3 tons per cubic yard. And we want to know what's that going to be in pounds per cubic foot. Tons per cubic yard is very commonly used in construction, materials, stuff like that. Yeah, concrete, trap rock, stuff like that. Your binders. So we have to get rid of tons. We're going into pounds. That relationship is 1 ton is 2,000 pounds. Very good. So the ton is gone. We need to get rid of the cubic yards going into cubic feet. That relationship is 1 cubic yard is 27. Remember, 3 feet in a yard, so a cubic is 3 by 3 by 3. So the cubic yards are gone. So on top, we've got 2.3 times 2,000 pounds times 1, which is 4,600 pounds. On bottom, 1 times 27 cubic feet. So divide it out. 4,600 divided by 27 is going to be 170.37. That's pounds per cubic foot. That's a relatively dense material, by the way. Most of your woods are between 45 and 60 pounds per cubic foot, depending on your density. Like a balsa wood's down around 44, 45 pounds. Some of your harder woods get up to close to 60, 61. Okay, so you might have a pressure that is listed as 8 ounces per square inch. You want to know what that is in pounds per square foot. So 8 ounces. Ounces and pounds are both weights, right? Square inches and square feet are both volumes. So we're taking this weight to this weight, this volume to that volume. That's a density. Yep, that's pressure. Like your air pressure in your tire would be PSI. That's 30 PSI in your car tire. A lot of your loads, and you're building a house, you got floor loads. Most of those are 65 pounds per square foot is your maximum floor load. Sure. So now we've got to get rid of the ounces. I'll put ounces on bottom, pounds on top. 1 pound is 16 ounces. And we have to get rid of the square inches, going to square feet. 1 square foot is 144. Good. We pounded that one into you enough, huh? So on top, we've got 8 times 1 pound times 144, which is 1,152 pounds. On bottom, 1 times 16 times 1 square foot is 16 square feet, which ends up being, is that 72 pounds per square foot? You don't always have to change both units. Sometimes you run into a situation where we have just one unit that needs to be changed. Let's say you are told you're being charged 34 cents per ounce. Well, we're used to what that's going to be in dollars per pound, right? We're not talking about that. So 34 cents over 1 ounce. We don't have to change the dollars. We just have to change the ounces. So ounces on top, pounds on bottom. 1 pound is 16 ounces. So the ounces do cancel out. We've got 0.34 times 16 is $5.44 over 1 pound. So yes, $5.44 per pound. A common one that we run into let's say you got a pump that's rated at 5,000 gallons per hour. More common rating for a pump is CFM. Anybody know what CFM stands for? Cubic feet per minute is exactly it. So let's take our 5,000 gallons over 1 hour. We have to get rid of gallons. What's the relationship between gallons and cubic feet? 7.5. There we go. And we have to get rid of hours. 1 hour is 60 minutes. So the hours are gone. So 5,000 times 1 cubic foot times 1 is 5,000 cubic feet. On bottom, we got 7.5 times 60 is what, 450 minutes. So 5,000 divided by 450 is 11.11 cubic feet per minute, which is actually pretty good. Most good pump is between 9 and 12 cubic feet CFM. So that's pretty good rating. Let's say we've got something that has a density of, I didn't do this one yet. Say we have a material that has a density of, let's be more realistic, 2.4 ounces per cubic inch. We want that in pounds per cubic foot. So 2.4 ounces over 1 cubic inch. We're getting rid of ounces. Going into pounds, 1 pound is 16 ounces. So that gets rid of the ounces. We gotta get rid of the cubic inches. 1 cubic foot is 1,728 cubic inches, right? So we've got 2.4 times 1728 is 4147.2 pounds over, 1 times 16 times 1 cubic foot is 16 cubic feet. Let's divide that by 16. 259.2 pounds per cubic foot. 2.4 ounces per cubic inch does not sound like that much, but that is an extremely dense material. Well, let's say you have a friend from Europe that tells you that they are getting a mileage in their car of 9 kilometers per liter. Is that good mileage? Let's compare that. Miles per gallon. So we've got 9 kilometers over 1 liter. So we have to get rid of the kilometers. Going into miles, 1 mile is 1.61 kilometers. Kilometers are gone. Have to get rid of the liters. Going into gallons, 1 gallon is 3.785. So the liters are gone. So on top here, we've got 9 times 3.785. 34.065 miles. On bottom, we've got the 1.61 gallons. So divide. About 21.16 miles per gallon. That's pretty standard. You must drive some little. Yeah. I get about 23. I've got a little SUV, so that's actually slightly on the low end, probably. Since we're on the kilometers and liters stuff, average price per liter. It's about $1.20 per liter for gas in Europe. Is that expensive? If you go to the pump and it was marked $1.20, you'd be a little bit happy, right? Yeah. What's that going to be per gallon? What's that? Yeah. It was up to $1, like $1.80 at one point. Yeah. It's gone down a lot right now. So we're not going to change the dollars, but we are going to change the liters. 1 gallon is 3.785. The liters cancel out. So we've got 1 gallon on bottom, $1.20 times 3.785. 454. So that's a little bit low, actually. Right now it's about 575, 580 a gallon right now. So $1.20 would be a good deal over there. To us, that's ridiculous. At one time, it was closing in on like $6.50 or $7 a gallon. $6.50 to $7 a gallon. They were paying $1.80 to $1.90 a gallon, or per liter, I should say. Yeah, it's not a pleasant thought. That was a dollar conversion. I don't know, a pound is what, like $1.30 or something like that, $1.20. Was it that big of a difference then?
But that was late 90s.
Sure. Like the U.S. dollar to Canadian dollar is the big difference. It used to be a U.S. dollar was like $1.40 Canadian, and now it's like $1.19 or something like that. Yeah. People used to make a lot of money just investing in currency, buying and selling currency. If you know what you're doing, if you know, still trying to. Oh yeah, he's gonna come back up. Yeah. That's why whenever there's any sort of a big military action like that, the price of gold usually starts to go up, because in a military action, if it can have a drastic effect on world economies, and when economies go down, their currency value goes down. Usually precious metals go up because they're constant, they have a value. So if you think about it, if the purchasing power of your currency goes down, that means it takes more of that currency to buy gold. Because like I said, the value of gold is usually pretty constant. The fluctuation in the value of gold is not the value of gold, it's a fluctuation in the value of the currency you're purchasing with it, usually. So if these were metric, let's say we have, let's see here, 2.3 milligrams per milliliter. And I want to know what that's going to be in kilograms per liter. I make that 2.3 milligrams over 1 milliliter. Now note, I'm not doing times here, I'm doing equals. I'm just going to convert each unit. Milligrams are going to become kilograms. On my chart, to get from milligrams to kilograms is 6 spots to the left. So I'm in my decimal point, 6 spots to the left. So I got to fill in some zeros. So that's what that comes out to be in kilograms. 1 milliliter going into liters. Milliliter to liter is 3 spots to the left. So I got to move 3 spots to the left, filling in those zeros. So now I have to divide that out. 0.00000023 divided by 0.001 is 0.0023 kilograms per liter. That's pretty small. Yeah. We might have 28 milligrams per square millimeter. We want to convert that into kilograms per square centimeter. So 28 milligrams over 1 square millimeter. We are converting to kilograms and square centimeters. Milligrams to kilograms is 6. So like that. Millimeters to centimeters is only 1 spot, but it's squared, so it's 2. Right? So now, let's look at some that are not quite as extreme. Let's look at 39 liters per 390 liters per square meter. Let's go milliliters per square centimeter. So 390 liters per 1 square meter. We are converting into milliliters square centimeters. From liters to, liters to milliliters is 3 spots to the right. That's 390,000, correct? Meters to centimeters is 2 spots to the right, but it's squared, so we have to go 4. So that's going to be 10,000. We divide that out. That is 39 milliliters per centimeter squared. Now, not all of our metric conversions are quite that simple, because we can end up with other units in there. Like when we have time involved, time is not metric. So if we have something like 25 meters per second, and I want to go to kilometers per hour. Well, I have 25 meters over 1 second. I can go ahead and change my 25 meters to 0.025 kilometers per second, but I still have to convert my seconds to hours. Now, I did 1 minute is 60 seconds, 1 hour is 60 minutes. 1 hour is 60 times 60 or 3,600 seconds. So the seconds cancel out. I've got 0.025 times 3,600, which is what? Is that 9? 9 or 90? 90 kilometers per hour. Okay, so I'm gonna let you guys spend the last 14 minutes here of our first hour doing some homework. This is gonna be in the big book. Page 257, exercise 813A and exercise 813B. And then on page 258, exercise 814. Then I also have a packet I'm going to give you. And in this packet, it's going to be pages 91 through 93.